Okay, we're back and they're no better. So we have this lovely problem with trig functions in it. Now what do you substitute? Oh, brilliant ones. If I substitute the cosecant and make it u squared, guys, I need you to pay attention and not have to fight through every little thing we do. Okay, if you substitute, the suggestion was substitute for cosecant. What's the derivative of cosecant? Cosecant cotangent. Is that going to work to get things to cancel right? If I do cotangent, the derivative of cotangent is cosecant squared. You could, but it actually will work quite sweetly if you just do the cotangent. And it should be screaming at you, I'm going to turn out to be you got a u on the bottom. It's going to turn out to be a natural log problem. So, derivative is negative cosecant squared. And so, I have du over negative cosecant squared, which cancels the cosecant squared. And you're left with a negative 1 over u, a simple integration. Which will become a what? A negative natural log of an absolute value of u. And you would last but not least need to do what? Put your cotangent back in and you got it covered. It's a thing of beauty. Works right out. The trick for you all come test time is figuring out which kind of problem is which. When they're all mixed together, how do you know whether it's a log? Okay. All right. This one I have with Z's in it. It's going to bug you if I do it in Z's if you want a different letter.
I don't mean to, but beta, like I cannot work with beta.
Okay. This is unique. Do we know how to integrate a natural log? We know that integrating 1 over u gives us a natural log. But we don't know how to integrate a natural log, and we won't know how until April. So yeah, your only choice right now, if you see a natural log in a problem, you have to substitute it out because you can't deal with it any other way. I did, because I want you to remember it. So that's going to give me u squared. But am I going to get this x on the bottom to cancel?
Well, then you do a 1 over x and x cancels.
Yeah, because when you do the derivative of natural log, you're going to get a 1 over x. Which means when you multiply it to the other side, the x is going to end up top again. And all comes out perfectly hunky-dory. I can't talk.
What?
Perfectly hunky-dory. Yeah, that's what I intended. Well, it kind of stuck all together. It kind of got jumbled up. So my x's are gone, and now I have to integrate u squared, which is what? Yes, u to the third over 3 plus c. Throw our natural log back in there for u, and we are done with that problem.
That was beautiful.
They're things of beauty the way it just works out.
You don't have to do as much algebra if you need it, which is kind of nice.
Am I going to do what? I'm now ready to go talk inverse trig functions.
Bring it on. What?
I'm ready to talk inverse trig functions now. Okay, before we can talk inverse trig functions, I gotta get you guys to remember your derivatives. What was the derivative of inverse sine? This is Romeo and Juliet. Yeah, she's in her house in the back in her room. We'll like it more now. And what was the derivative of inverse tangent? She's tanning, so she's not in her house. Or x squared plus 1, it can be either order. And then last but not least, secant. Yeah, he's seeking her, so he's outside her balcony. On a ladder, absolute valued. And whoa.
And she's next to him.
Yeah, she's up front because she wants to talk to him. Yeah, it's the love of her life coming.
Remember when you were Juliet and I was really young? I just feel your dad's face.
It's funny. Yeah, I don't know why you let me know the other day. I thought he told you to skip on your bed. No, I asked.
Now, here's the interesting part for you all. Now, we're going to go backwards. So, you're going to be given these weird fractions, and you're going to have to look at those fractions and go, oh, that's an inverse trig function. Nothing that there is going to scream to you, oh, an inverse trig function.
Oh, no.
So, if you're given a square root of 1 minus something squared, you know it's going to integrate back to be an inverse sine. And the one that's probably the toughest is if you are given a tangent one where it's 1 plus x squared. That's a pretty simple little fraction. You've got to notice that, oh, I could make that into inverse tangent. Whoops, I shouldn't have been writing u. Sorry, it should be x's up there. And probably the one that's the easiest to spot is a secant. So, if you're looking at those, particularly when we start mixing it with other things, you're going to have this debate of, is it just I should u substitute the quantity and the roots? It's just a normal u substitution, or is it an inverse trig function? It's what's next. And it's fun. You've been sitting here telling me those others were too easy, and I feel the need to challenge you.
Get rid of that name.
Don't whine at me on Friday afternoon.
Slide 3.
This is slide 4. Yeah.
We're on slide 4. A 5?
A 5, yes.
Really good job.
4? A 5. That means we have one page.
Whoops, that's x squared on top there, sorry. X squared on top, I copied the wrong thing. Okay, right now, particularly with today's assignment, you're going to know you're on the page of inverse trig functions, so it's going to be fairly obvious that, oh, it's got to be one of the inverse trig functions. Okay, so which one is this sort of kind of set up like?
Sort of kind of like the same side.
Yeah, it's a root, she's got a house, she's hiding in the back, so it's kind of like a sine one. But for u to get this to integrate, that has to be 1 minus u squared. Close. I need that to be 1 minus u squared. So you have to ask yourself, what am I squaring to make 25x to the 6th? I'm squaring a 5 fourth. You multiply your powers when it's a power to a power. So it's 5x cubed that you actually are squaring. So that's what you have to substitute out because you need it to become u squared, not just plain u. So So you'll have to ask yourself, what am I squaring? And that's what you're going to sub out. We would sub out 5x cubed. And if you think ahead here a little bit, the derivative of this is going to give us a 10x squared, which is convenient for what's on top of this fraction. 15, sorry, heavens. Okay, it is Friday afternoon.
Yes, it is.
So you have du over 15x squared. Okay. So what happens, children? The x squareds cancel. And I could reduce the 6 and the 15 too, couldn't I? So that could become a 2 and a 5. So I'm actually going to pull out a 2/5 out front. Everything else on top is gone, so I just have 1 over the square root of 1 minus u squared times du. Is that our proper inverse trig function that we need? Yes, it is. Looks like Juliet's been sinning. And so, yes, our final answer, well, actually, I guess we're not quite to our final answer. 2/5, what's this whole thing become? Inverse sine of u plus c, and then at last you would have to put back in the 5x cubed. That whole thing is this rule. It's that whole expression. It's that whole inverse trig function. That's why you got to spot it as a whole inverse trig function. Now, why did I not list cosine, cosecant, and cotangent? They're just the negative versions of these, and when they're integrating, they don't bother with them. They always, children, we aren't caring about the size of Dylan's boots. When they're integrating, they always do it in the primary three. They do it in sine, tangent, and secant. You won't see them integrate with cosine, cosine, tangent, cosecant.
Nice.
Cosecant. You won't see the cos. Cos don't happen. All right. It's time to get mean. How are we doing? I am on the last page. Probably not. Can I do this in 2 minutes? We might as well stop now.